Now we're going to look at what I call Form 2, where there's logs everywhere. I think this is actually easier, but you cannot get them confused on the test. So we're going to, again, combine the logs using our log properties, and if our coefficients, we have to make them exponents. So now we have a log equals to a log, which means by the property of equality, you can say those two things are equal. We solve for a variable, and again, we check. So a little bit easier. So let's just dive right in. So again, we have this plus, so that means I can multiply these. So log base 2 of x squared minus 5x equals log base 2 of 6. Don't skip these steps. Show all your steps. Now, because of equality, everything matches. Log 2 matches log 2, which means this has to equal to that. So we can say x squared minus 5x is equal to 6 by property of equality. Again, we have a quadratic, so let's set that equal to 0 and factor. Be careful, 2 times 3, not going to work with the signs. We need a minus 6 and a plus 1. And so we have x is equal to 6 and x is equal to negative 1. And now we're going to check. So let me just kind of erase this. So I have a, and now if I put in negative 1 for x right there, that would be the log base 2 of negative 1. Can't have that. If I put in 6, that's positive. If I put in 6 minus 5, that's positive 1. So 6 is my only answer. Again, don't erase that answer. Just put a mark through it. It's an extraneous solution, meaning extra. It came about as we were working through the problem, but it did not check into the original equation. Right, so we have natural log. This is minus. So we have x plus 4 divided by x plus 1 equals the natural log of x. And again, because those are the same, those are now equal. So we have x plus 4 over x plus 1 is equal to x. Have a fraction, so let's multiply both sides by that denominator. So we have x plus 4 equals x squared plus x. One more time. We have a quadratic. Let's set it equal to 0. But what happens when I subtract x from both sides? Those go away. So I could say x squared equals to 4. That's one option. So if I had x squared equals to 4 and I took the square root, I just had to make sure I have plus or minus. Or I could, and I'm going to come up here, sorry for the messiness, or I could have said, if I had 4 is equal to x squared, again, set it equal to 0 and factor, and that's the difference of two squares, and I would have got negative 2 and positive 2. So either way, I get both answers, and you need to check both answers. If I plug in negative 2 here, negative 2 plus 4, that's okay. But if I plug in negative 2 there, plus 1, that's negative 1, can't do it. But if I plug in positive 2, that gets me 6, that gets me 3. So positive 2 would be the correct answer. So emphasizing, check your work, don't erase the extra answer. Okay, so now here is an example of where you cannot combine the logs yet. We don't have a property that says you can just divide those. This 2 has to become an exponent first. So we have log x squared minus the log of 7 equals the log of 100. Now we can use the property of a log that says we can divide those. Now we can use our property of equality, multiply both sides by 7, and 700 is not that pretty of a number. It's not a perfect square. So I'm just going to go ahead and take the square root. I'm going to remember plus or minus, and 700 is 7 times 100, so that's going to be 10 times the square root of 7. Now you might not know what that is, but when you come back up here, this is the only place for x, the log of a number. Can the log of a number be negative? No, it cannot. So x equaling to negative 10 times the square root of 7 is not positive. I'm sorry, not possible. But x equals to positive 10 times the square root of 7 is. Again, I need to see that plus or minus so you can get full points on the test. All right, so this one is kind of written a little backwards, but that's okay. We have log base 3 of 4 minus x. We have a plus sign, which means I can multiply those two expressions. So let's see, that's going to be 2x squared. 13x plus 16x is 29x. Wow. And then 8 times 13. So let's see, 8 times 3 is 24. It's 104. Ooh, some big numbers. But again, now I set those two equal to each other. I'm going to subtract 4 and I'm going to add x. So I get 0 equals 2x squared plus 30x plus 100. Some big numbers, but notice they're all divisible by 2. So I'm going to factor out my 2. That's a little bit better. So what multiplies to get 50? 25 times 2, but 5 times 10 is going to get me 15 in the middle. So I'm going to say plus 5 and plus 10. Now every expression that has an x, you set equal to 0. 2 can't be 0. So you could have divided both sides by 2 and it would go away, or just know 2 can't equal to 0. So we have x is equal to negative 5 and x is equal to negative 10. So you might be thinking, oh, well, they're both negative, throw them out, no sense. Answer. No, no. We've got to check it in each one of those. So let's see, we have 4 minus a negative 5. That's 9. That's okay. Check it here. We have negative 5 plus 8. That's okay. And here we have 2 times negative 5. That's negative 10 plus 13. So negative 5 is a keeper. Now let's try negative 10. So we have 4 minus a negative 10. Okay. Negative 10 plus 8, right there. That's negative 2. So I just stop. Can't happen. That's our only answer. So you're going to get some practice of factoring, knowing your trinomials, and your properties of logarithms. Let's do our last example. We're in base E, but that's okay. Properties of logs are the same. So I'm going to multiply those together. So I have x squared minus 3x minus 4 equals the natural log of 3x minus 12. Now I can set those equal to each other. And I really would like for you to show all your steps here. If I subtract 3x and add 12 to both sides. Okay, so factoring that, so I think 4 times 2 will work nicely, being both negative. So I get positive 4 and positive 2. Two positive answers. Got to check. Okay, I'm going to check right over here. So remember, I have to check every place. So if I plug in a 4, so I have for x minus 4. So if x is 4, I would have 4 minus 4, which is 0. 0 is not in the domain of your logarithmic function. It has to be numbers greater than 0. So automatically, I can get rid of that. Now let's try 2. So I have 2 minus 4. That's negative 2. Can't have that either. So my answer is no solution. Now when you're doing your homework and you just look at the answer and it says no solution, you stop right here. That's not good enough. You've got to go through the whole process, show that you checked, and understand why you ended up with no solution. So remember, we have this form where we have all of logs, and you can use the property of equality. We also have this form where you have the constant, where you have to use that exponential form to get rid of, if you will, the logarithm.